This is part 1 of our DED lab. This is circuit schematic 2 here, which is a 2 NOR gates and 3 NAND gates. You can see how they're all connected. And here's our circuit here, live. Okay, you have it's a whole jumble of wires in here. But yeah, it's connected, right? So now the two inputs are at 0, 0, which will give a 0 at Y. Here it is, the truth table for Y. Supposed to be 1 here, 1 here. Okay, so when we hit input A, it'll come on. Now input B comes on. But let's just stop there. That's fine. And then for both, nothing happens. And there we go. That is our circuit. Thank you. Again, the same setup as the time circuit. Now this time we're just gonna, to find the amplitudes, we do practically the same thing. First, let's go to source 1. Okay. Here we have our source 1. What we do, basically we go up until we find like we're on level with the second source. Our leveled part is around here. It's not going to be perfectly flat, but it's really relatively, we can approximately flat there for our own. It's, what was it, 33 volts right there. Okay. Then to find the low, switch to the second channel, go down here at the second source, and then we look for 0. The lowest part on our second.
Yeah, okay.
Yeah, this part here is our second channel, the output channel.
It's 0, it's alright.
Yep. And the flat part here corresponds with, well, for lucky for us is 0. Right there, so make it easier. So that means that will give us the voltage output.
The voltage output, yeah.
You divide by 10.
Then you divide by 10 again, and you get the answer 3.32 volt.
Yep. That's for the high, and then the low,
The low is 0.00 volt.
Yep. This is our circuit. There's NAND gates in series. This is the channel 1 inputs coming directly from the clock here. Ground. And here is the channel 2 output. Right there. Circuit. Just edit that part out. Okay. Here's our
Okay. Here's our result from the DSO. So
yeah. To get it to change
Channel.
the first channel, you have to to get the input. Hold on 1 second. We switch to cursor 1. First we have to get it to the middle input. Now for middle input, it's around roughly around
Here?
here.
Yeah.
Roughly.
then change to second cursor.
Second
Moving.
channel, second cursor.
So cursor right there.
Moving
We use this out now to switch the cursor. Now we have to move it to the middle.
Yeah, alright.
Is roughly about there, and then here we get our answer.
Since this is a 10 to 1 ratio, we divide the answer by 10 and we get 4 nanoseconds. And here is our 4 nanoseconds answer. Here is our circuit for port 3 of the lab. We have to connect a resistor to the lead and form a NAND gate. So from our calculation, the resistor we get is 120 ohms. So this is the resistor of 120 ohms, and this is our LED. This is our whole circuit, the NAND gate. Okay, here when we input, as you can see, the LED light up. So yeah.
And that's all, folks. This is our circuits. This is what we got when we do the Carnot map for circuit for part 4. Here it is. This is the sum of products, and I will convert it into this using the Morgan's theorem, and this is the circuit we get. Here we mapped out our circuit this input, which is this button here, is A. This one is C, which is this button, and our C is here. Yeah, is here. No, this one. Yeah, sorry. Okay, so now when we press each button individually, nothing happens, as you can see. Now when we press two of them, let's say A and B, the light comes on here. This is our outputs. Now let's try
B and C.
B and C.
Alright.
There we go.
And
And
A
then
and C.
A and C, yeah. Let's try A and C.
Alright.
All three are working. As you can see, this is our setup. This is the 4 2 inputs NAND gates, and this is the 3 inputs NAND gates. Connected it there. Very complicated, yes.
Done.
Okay, thank you.